In this video, we'll take up the homework on verifying properties of a circle. So for question 1a, they ask us to find the coordinates of the midpoint of DE. So just plug in the midpoint formula and you're done. Find the slope of chord DE. Just use the slope formula and you're done. And verify that OM is perpendicular to DE. So I did the math, and yeah, the slopes are negative reciprocals, so they are perpendicular. For 2a, verify that they're equidistant. So I solve for the slope, solve for the length from each of those points to point C, and they are the same. And then draw the circle. So I didn't do the drawing, but you can easily draw that. I believe the answer key has a nice picture. My diagram won't look nearly as pretty. Okay, for question 3, how do you know the origin is the center of the circle? It is the center because all the points on x squared plus y squared equals 34 is equidistant to the origin. So the origin must be the center of the circle. Verify that the points lie in the circle. Just do a left side, right side check. So I did a left side, right side check, and the other one I did I checked the point. Basically, I'm checking a concentric circle, and that concentric circle is identical to the circle that was given to us. So that means that -5, -3 is on the circle. So either way, whatever you feel more comfortable with, both are great ways of proving that the point is on the circle. For question C, verify that the line through the origin and the midpoint of the chord AB is perpendicular to the chord. So I just basically had to show that the slopes are negative reciprocals for slope of OD and slope of AB. For question 4, verify that the center of the circle lies on the right bisector of chord XY. So this is just checking the property. So I showed that the slope is, the y-intercept is 0. So since the y-intercept is 0 of this line, then the center 0, 0 is on the right bisector of the chord, and 0, 0 of course is the center of the circle. Sorry, I'm just verifying. I'm just double checking the question. So for I verify that the center of the circle lies, so 0, 0 is the center of the circle, and it's on the right bisector of chord XY. For question 4b, find the radius. So I know this is in the previous unit. You have a point on the circle, you can solve for the radius of the circle. You have 2 points on the circle. So anyways, I picked one of the points and I solved for the radius by punching it in to the equation or the formula. Okay, so question 5. Oh boy, find the right bisector. So you have to find the circumcenter. So right bisector of DE, EF, bam, 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 linear system. The center is -2, 2. Question 6 is really nice. I really like this question. But it really came out of left field. It's a great question. It's a great property of a circle. So you have the diameter and you have 2 chords. The angle here must be a 90-degree angle. Okay, if this is the diameter, this must be 90 degrees. You must have a right triangle. So basically, I show these. This is the radius, and this is radius. This is radius, which means the triangle OAC and triangle OCB are isosceles. So these angles must be congruent. And then if these angles here, OCA and OCB, okay, sorry, let me back up a bit. So angle OCA, angle BCA, angle OCB, yes. So angle OCA and OCB, if you look at it, this makes angle BCA. Okay, so you have double the angle of BCA is 180 degrees, then one of them must be 90 degrees. So that proves that this is a 90-degree angle here, angle ACB. So as long as you can understand that this angle here, OCA and OCB is equivalent to angle BCA, then the rest of the question really makes sense. Okay, so that's the homework solutions on verifying properties of a circle.